Well, this is a bit condensed presentation. It's normally around 1.5 hours. It should now be in 10 minutes, so it will only be a high level, an overview of where we are moving and how we look at the infrastructures for genomic and genomic research. First of all, how many know Hitachi as an infrastructure and storage provider? Oh, good, at least a few. And after dinner last night, I got comments about excavators, power tools, Hitachi amplifiers, etc. So we are in a vast majority of fields. But how many of you actually knows Hitachi Medical and Life Science? Anybody? One? Oh, interesting. So we have a global span, 9 regional offices, where we do research and manufacturing. And we've done a lot of different paths, from imaging to X-ray to DNA sequences, proton beam, therapy, etc., etc. We started to build and research DNA sequencers in 1982. So by today, we hold over 100 patents in DNA sequencers. Useful for most people. And we have recently alliance with Cambridge to develop nanopore sequences. So we do a lot within the area. And now the last year, we have started to collaborate, crossbreed between data systems and medical. So now our research teams and developers sit down with the medical side to discuss what challenges, how should the infrastructure be built to support your daily research and your daily work in a good manner. And like we heard, the NGS now has changed the game, where we see costs going down for sequencing. It will be easier, less time consuming, so we're generating more and more data, and that needs to be stored, managed. That we also heard about a lot of yesterday. We have the external processing infrastructure, still need to support the HPC solutions. Security concerns are raised when sharing, when storing, guaranteeing the data integrity. Requirements for long-term storage and archiving. How do we share and collaborate on our data sets? A lot of people now building their own silos. This is a common challenge that we see. Well, we store it, but how do we find it? How do we search? And here we see 2 trends in the market, and also from our medical side and requirements. For storing the data, moving to object-based solutions to free up the data from the application, normalization of the data, being able to handle extensive metadata tagging, also from different organizations adding their own to the same data sets during the life cycle of the information. Role-based authentication, guaranteeing the data integrity, the compliance for long-term archiving, and moving to object storage with high intelligence. We can also get rid of the backup requirements. We were talking about yesterday working data sets, backups of the data sets, and archiving. But having the right solutions now for large amount of data, and the right solution can get rid of one of the costly solutions in backup, and still maintain and retain the data integrity and searchability, which you don't have in the backup solution. We can also make easier data distribution and sharing with object-based storage solutions. And we also see new service-based delivery models. We'll be discussing cloud solutions today and yesterday. Why we see that? Time to market, handle growth, handle new products, projects, short-term projects that need the infrastructure for shorter term, or if you need to ramp up for some analytics, you can do that as well in adding cloud services. So we see a combination of cloud service and local infrastructures, so that don't end up what we saw in previous presentations, while you have data in local, but you cannot access it publicly. Tie the infrastructure together, have the same metadata and storage repositories, so you can transfer data back and forth. So the enabler from Hitachi is our object-based platform, whether building on-site private cloud solutions or combinations, those covering traditional storage. Is our Hitachi content platform, which we use to secure the data. It's built on traditional storage, so no purpose-built storage array or something like that. The traditional storage can be whatever storage you like. We add some intelligence. We self-manage, object-based, self-healing, self-organization, self-provisioning to reduce the management part. So we have automated a lot of the management side. We have added additional self-protection of the data, self-healing, error corrections, guaranteeing data integrity over time, so we can reduce and remove tape backups. It's built for long-term archiving with hardware and lifecycle management and data lifecycle management to guarantee the data integrity throughout migrations and data movement between different repositories, between cloud and local, between this generation and next generation storage, and especially extensive metadata management. So you can tag the data set with your local metadata, search, find. We can let other organizations, units, research team, metadata tag the same data sets and maintain the infrastructure. We can also set who has the right to search different metadata sets, so we can combine joint efforts and results in the same data sets, being able to manage different metadata repositories. And you can present the data and information with global access using HTTP and REST protocols directly to the storage, or through REST APIs, integration with a lot of applications. This is our base and foundation for our genomics solution in storing and handling and managing the information and data. Hitachi Content Platform. So we can deliver from the sequencers with storage for working data sets, the compute side, HPC powered, platform computing, data repository and archive for the storage and data integrity part. We can ramp up basically with cloud services, both compute and storage. And we can also share and mobilize the data from our infrastructure, all built in the single pane of management, single pane of glass to the whole solution. This can be an on-site, or, like we have done now, last year, an integrated approach where we have combined infrastructure, data management and software. The infrastructure is based on our hardware and the base is the content platform. We have a project with NI, with Genus and Gene Torrents, management of genomics and data. And we have also collaboration with ICGC, one of the largest genome cancer repositories in the world, where we now have set up a cloud service for genomic research. So So both infrastructure and cloud will reckons to hold about 10 to 15 petabytes of data, normalized, searchable, indexed by 2018, open to search for reference. Private cloud infrastructures, you can connect to your local infrastructure or build a private cloud for you or access resources in the public cloud. So from the same infrastructure you can transfer data, you can reference data with full interoperability. So develop cloud and on-premise reference architecture. Today we have several customers already using this. We have a lot of people using POCs now, these solutions. So, create a private cloud. We heard that yesterday. Create a infrastructure as a service part. Bring on your own applications. Bring on your own data. Then connect that to the local infrastructure. So it's not built-in dependencies. Bring your own application. Flexible compute. You need more, ask for more. And it's cost-effective alternative to in-house infrastructures. And also ramp up and ramp down. So by using our solutions, we will now sit down with the medical side and the computing infrastructure side. We create a unified access, consistent metadata management, enhanced searching and access, and also use standard protocols, open protocols, no proprietary protocols, HTTP, REST, S3. This morning I've heard all of these 3 protocols mentioned, and those are our standard protocols for accessing the data as well, and management. New security functions, authentication, private cloud infrastructure, authentication. We can go deep down in a lot of these topics, but well, we have the time and coffee waiting. So this was to challenge you to think about Hitachi when you're thinking about next generation infrastructure for next generation sequencing. Speak to us, let us give you input, and see what if we can do something together. So accelerate your research with flexible delivery models for on-site as a service models, reliable, scalable performance infrastructure to meet the demands. We build multi-petabyte sites today and also hold those to reference for you. Because in the future, I don't think any of us think that all of us are going to build our own multi-petabyte sites. If you would like so, cost and management. So instead, use a central repository for referencing, where we have normalized data, where you have extensive metadata management. So that was a very quick, brief 10 minutes of a 1.5 hour session. If you have any questions, feel free to email or access on the web.
Thank you very much.
Vi är